Hello, chemistry students. Today we're going to take a look at the lab that is on page 851 of your honors binder. If you're in standard, I don't know what page you are on, but it's called Comparing the Heat of Combustion with the Heat of Fusion. So what we're going to do is use candle wax for both of them. So obviously we want to use the same chemical so that you can compare the two processes. In your lab notebook, you want to write a purpose. You want to include a hypothesis. If you look in the directions, the hypothesis is to predict which one, delta H of combustion or delta H of fusion, is going to be larger. And then you also want to prepare a data table for both parts. So heat of combustion data, we're going to have water in a can. We're going to have the mass of the candle before and after because we're not burning the whole candle. And we're going to have the initial and final temps of the water. For the second part, for the heat of fusion data, we're going to have the mass of the glass test tube and the mass of the test tube with the wax. You'll note that I already have those numbers in there. We'll talk about why that is when we get to part 2. The mass of the water in not can, that should be the styrofoam cup, and the initial and final temps of the water. So prep your data table for those pieces of information, and then come back and we'll start with part 1, the heat of combustion. So for heat of combustion, we're going to use this calorimeter that's called a chimney. So there is a bigger can on the outside. Notice the diameter is pretty large and it's got holes cut in it. That's so that we can get air to the candle, which is going to be in the bottom. We have a smaller can that gets inserted into the larger can and is held above the candle with a glass stirring rod. This smaller can is where we're gonna put our water. So we're gonna let the candle burn for about 5 minutes, see how high the temperature of the water has risen, and then we'll use that to collect our delta H. So a couple pieces of data that we need to get. Let's measure the mass of the candle. So I put that on there, and at this point, did I tear it? So the candle weighs 16.20 grams. And then we'll measure the water. So I'm going to put the empty can on here. I'm just going to zero it. And then we'll add some cold water. This is cold water from my fridge. It doesn't have to be deionized water because the chemical is never touching this water. So having it be cold refrigerator water from the tap is fine. So I'm going to fill it about halfway. So that mass is 208.61. Okay, so we'll get the chimney set up and take the initial temp of that cold water. I feel like we should be playing the Jeopardy song right now. Do, 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 do. Okay, we are at 8.2 for the initial temp. So now we're going to light the candle. I'm going to put the chimney over top, and we're going to let the candle burn for about 5 minutes. So we'll pause the video and then we'll come back. Okay, we'll see you in a few minutes. Go. So we're back. We've been letting this burn for a good 5 minutes. We're going to blow the candle out and record the highest temp we get to. Okay, so I'm going to keep stirring the water till we get to a maximum temp. Right now I'm at 19.0. 19.1. Okay, I'm going to call it at 19.1 degrees Celsius. Okay, the other thing we need to do is get the mass of the candle that's left over, what didn't burn, because remember, that energy that we measured that caused this temp change is from the candle that burned. We got a huge amount of candle that didn't burn. So we want to weigh this and see how much of the candle didn't burn. Oop, let me make sure I tear that first. Okay, we are good. So the mass is now 15.84 grams. So you can see we didn't burn a whole lot of candle, but it's what we have to work with. Okay, so we'll work that data up in your calculations using, again, the equation MC delta T for the surroundings, which is our water, is going to equal M delta H for our candle. That's a good E. Okay, so figure out what you need to put in where. We're trying to figure out what the enthalpy of combustion is for the reaction. All right, so that's part one. We're going to shift gears to part two now. So for part two, we're going to move back to the styrofoam cup that we used for heat of solution. I've got candle wax in this test tube. It is solid right now, but we want to melt it. So I'm going to put it in, this is hot water that I put in the microwave, got it to boil. So I'm putting that in the hot water. If you come and look closely, you can see that it's starting to melt already. Candle wax melts at something about 78 degrees, I think. So the very hot water is going to melt the candle wax. We can't start anything until the wax is all melted. So let's talk a little bit about what we're doing. So if you look at the data table, I've got two masses in there already. The mass of the glass test tube, I had to weigh beforehand and then put the wax in there and melt it so that it was ready to go. So I did this many years ago, weighed an empty test tube, and I etched the mass onto the outside of the test tube. So I know that the mass of the test tube was 19.88 grams before I put the candle wax in. Then I put a bunch of candle shavings in there, melted it, and then today we weighed those shavings when they were obviously solid, not liquid, and we found that the wax that I put in the test tube plus the test tube weighed 26.94 grams. So take the difference, figure out how much candle wax is actually in the test tube. We also need the mass of water in, not the can, but the styrofoam cup, and we need temperature. So while the wax is melting, again, you can see it's getting more clear because as it melts, it goes from being opaque to clear. We're gonna deal with our styrofoam cup. So once again, I'm gonna just tear the styrofoam cup and add water. I need to make sure that the water is high enough to cover all that candle wax. So I'm gonna put a good amount of water in here. Again, this is cold water that I got from my refrigerator. Okay, so the mass of our water is 310.72. And I also need to get the temperature of the water. I think I'm gonna wait to do that till our wax all melts. Can you see the opaque stuff getting smaller and smaller? That opaque stuff needs to completely disappear for this part of the reaction to work. So I'll put the thermometer in here. And then I think we're just gonna pause for a few minutes until this all melts, and then we'll come back and continue the lab. So we are back. Our candle wax is completely melted now. So if you wanna come look, you can see that it is completely clear. So now what I need to do is I'm going to pull the wax out of the hot water, hold it in the air until I start to see it go opaque. Because what we wanna do is we wanna collect the data of just freezing. So we don't want the energy that's being released as the candle wax cools. We want the energy being released as the candle wax freezes. So that's what we're looking for. So at this point, my cold water is at 9.0 degrees Celsius. So the only thing we need to do is pull the wax out. And like I said, we're gonna keep our eye on it. This shouldn't take too long because it wasn't in there. Yep, there it goes already. Okay, sorry, did you see it? Probably not. I gotta be fast. But now what we wanna do is, as it freezes, it's gonna give off some energy because we've gotta reform those IMFAs. So I'm gonna collect the temperature as it freezes. Right now I'm up to 9.8 degrees. And we are going to, this is gonna take a little while, so we'll come back when the temperature is stabilized. So we'll be back in a few. So we are back for the last time. This has been, the test tube with the wax has been in the cold water cooling and pretty well stabilized at this point. So we are going to call this final temp as 11.4 degrees Celsius. Oops, goes my whiteboard. So if you take a look at the wax, it is now back to not being clear anymore, but it is all cloudy. Sorry that I rushed so much. We didn't want to miss that start of the temperature. All right, so now we've got all our data collected. So once again, we're going to use the equation MC delta T of the surroundings equals M delta H of the candle for solidification, however. So you can figure out how much wax we have, you know how much water we have, you know what the delta T for the water was, you want to figure out the delta H. This is a really good lab to review a lot of the ideas. You're going to use bond energy to figure out the theoretical heat of combustion. So you've got to write a balanced equation and use the bond energy table for all that. You're going to talk about what kinds of bonds were involved in these two processes and just use a lot of the knowledge from the unit to address the analysis questions. So follow through on everything. Think about what I did and what I could have done wrong, where numbers might not be quite right as far as sources of error goes, and let's see what you come up with. Thanks for watching.